Hey everybody, let's talk about the lab report for your experiment. So just start off with the introduction. So you just say the purpose of this lab report, the purpose of this experiment was to compute the coefficient of kinetic friction for different materials. And then in this section you can have references to if you found any research papers or things like that. That's where you mention them. And then you'll cite those references at the very end of the lab report in the references section. And toward the end of your introduction, you can also have a hypothesis. So you say, I think that this material will have a lower kinetic friction than this one. So this is where you can state that in the introduction section. Okay, and then next is the methods. So you just explain in enough detail that someone who reads your report can replicate your experiment. And then in this section, you can also have a picture of your ramp setup, where you had your object here, and it was sliding this way some distance. And then it's going at some speed, and you're trying to measure the coefficient of friction here, some mu k, coefficient of kinetic friction. And then the next section is your results section. So you say, okay, this is a table of my results, and then you show a table. Let's see, what was in your table? You had 10 trials and you're measuring time for different materials. Say object 1, 2, 3. Okay, so this is all your data. And then here you can, you should just take your spreadsheet and then just paste the table directly. And then you can compute the mean and the standard deviation here. Okay, and then at the very end, the coefficient of friction. Okay, let me talk about this in a minute, the details of it. Okay, so this is your results, and then next section is analysis. So here you can discuss sources of error. You can talk about the precision of your measurements, which that comment comes from the standard deviation. Okay, and then the conclusion. You just restate your hypothesis. And then just if your results support or refute that hypothesis. And then references. This is where you cite the references that you mentioned over here in your introduction or anywhere else in the report. Okay, how to compute this coefficient of friction. If your ramp looked like this, right, and then you start at the top of the ramp at rest, and then it slides down some distance to over here, and it's going at some speed. Right, so what does the free body diagram look like of the object as it's sliding? I'll draw it. Let me make some space. Okay, so as your object is sliding down the ramp, it's normal force, friction, and weight. Okay, and then if it slides this way, I'm going to pick a coordinate axis going that way, and then perpendicular to that. Okay, and the angle is here, is the same as the angle being right here. Okay, so let's write Newton's second law, split up into components, x and y components. So in the x direction, we got mg sine theta minus that friction equals mass times acceleration. Okay, in the y direction, we got n minus mg cosine theta equals mass times acceleration. Since it's only sliding in this direction, there's no motion in this y direction. So the acceleration in the y direction is definitely 0. Okay, and then we also know that friction is proportional to normal force, or that's the coefficient of kinetic friction. Okay, so if we solve, let's see, let me number these. If we solve equation 2 for n, from equation 2, n equals mg cosine theta, and we can substitute that into equation 3, this one. So friction equals mu k n, but n is mg cosine theta. And then we can take this and substitute it right there into equation 1. Right, so equation 1, mg sine theta minus friction, mu k mg cosine theta, equals mass times acceleration. Okay, so that means, let's see, you see mass is non-zero, so you can divide both sides of the equation by something that's non-zero. So we have an expression for the acceleration. Let's see, I can factor g out of there. Okay, so we have an expression for the acceleration. Notice that this is constant. Which means we can use kinematics for constant acceleration. So for constant acceleration, this is true. And this is true. Okay, so which of these should we use? So let me substitute this here and here. So let me just rewrite it. Actually, I'll just plug it in right here. Let me make some space. Okay, so g, this is ax. I'm writing right here. And then also right here, I'll just plug it in. Okay, so of these two equations, which should we use? So it's always a matter of figuring out what we know and what we don't know. So let me just underline what we know. So x, that would be, let me grab our picture. If we start here, if we make a coordinate system like this, and then the initial position x naught is 0, and then the final would be over here, some distance d, so this is known, it'll be d. Okay, then we're starting at rest, so v naught x is 0. We know g, you measure the angle theta, you measure the time, which means the only unknown is this. Okay, next, the initial velocity was 0. We know g, we know the angle, you measure time, we don't know coefficient of friction, and the speed. Okay, so we weren't really asking about the speed, we're just after the coefficient of friction, which means we just need this equation right here. So let me just rewrite it. It looks kind of messy, right? So here was the final distance d, and then we cross that out, 1/2 g sine theta minus mu k cosine theta t squared. And the only unknown is right here. Right, so solve for mu k in terms of everything else, d, theta, g, and time t. And this is how you compute the coefficient of kinetic friction for these three objects, right? So then that goes here and here and here. Okay, so I hope that's enough so you can finish your lab report, and then like don't throw away your ramp if you built something, because we're going to need that for the next experiment where we're going to roll things down the ramp as opposed to sliding things. So it's going to roll. Okay, so let me know if you have any questions, just post to the forum, and I'll see you in the next video next week.